All right, so I'm going to do several problems with you. On the review, what I do not complete, you have to do on your own. This will be worth 42 points. If it's on the review, it will be on the test. Okay? So I'm going to pick the problems to do. If you have any questions, let me know. Anybody have any questions before we start? Okay. All right, I'm going to start with number 1. We're taking the fourth root of 567. So put in your calculator and see if 567 has a perfect fourth root. If you get a decimal, it does not. All right? And I did that and I got a decimal. But it might have a perfect fourth factor. So I'm going to use my factor tree to help me. Oh, whoops, 567 it should be. All right, so 567, it's not even, so it won't divide by 2. It does divide by 3, though. 3 is prime. 189, I'm going to see if it divides by 3 evenly. It does. 3 times 63 gives me 189. 63 divides by 3 to give me 3 times 21. 3 is prime. 21 has factors of 3 and 7. They are both prime. Okay? So I like to write all of my prime factors out. 1, 2, 3, 4 3s. And a 7. If I'm taking the fourth root, I need 4 identical factors, right? So is there a perfect fourth root? Yes. What is 3 to the fourth power? 81. And you just want to make sure that 81 times 7 is 567, because if it's not, you missed something somewhere along the way. Okay? So I'm going to replace 567 with 81 times 7. Now, is x a perfect fourth? No. Can I rewrite it? No. There's only one x, right? I can't add more x's to it. All right. Anything that's a perfect fourth, I'm going to take the fourth root and put it on the outside. If I can't take the fourth root, then it stays under the radical. So can I take the fourth root of 81? What is its fourth root? 3. That goes on the outside. Can I take the fourth root of 7? No. So it stays. What about x?
No, it
Stays. Can I do anything else?
No.
Simplified. Everybody cool with that? Yeah, because the fourth root of 81 is 3. Oh, my mistake. No, that should be, I did not mean to do that. Thanks for pointing that out. My mistake. Everybody cool with that? All right, look at number 3. All right, on this one I have a number already outside the radical. It has a coefficient, right? So anything I take the cubed root of, I have to multiply by the number that's already out there. No big deal. So is 64 a perfect cube? I have 1, 2, 3, 4, 5, 6 2s. So that means I have 2 perfect cubes. If everything I have is a perfect cube times perfect cube is perfect cube, right? Y'all already said it was a perfect cube. And I just wanted to show you my math. The cubed root is 4. So 4 times 4 times 4 is 64. All right? So I don't need to rewrite it. Is m to the 6th a perfect cube? All right, so remember, 6 is not a perfect cube. But as an exponent, the rule's different. Remember? If the exponent divides by the index evenly, then it's perfect. 6 isn't a perfect cube. As an exponent, it is a perfect cube. Okay? So the -2 is already outside the radical. All right. What's the cubed root of 64, did we say? Times 4. What is the cubed root of m to the 6? M squared, because 6 divided by 3 is 2. So since everything under the radical was a perfect cube, am I going to have a radical sign in my answer? No. So what's my final answer? Negative 8m squared. Coolio? Any other? I'll do one more in that section if you need me to. Number 6. All right, so we have a coefficient of 3. Is 64 a perfect fourth? No. All right, so I'm going to do a factor tree. I know 8 times 8 is 64. Does it matter which two factors you start with as long as they're actually factors of the number? Could we start with two different factors? Yeah, because in the end, we're going to get the same prime numbers. So 1, 2, 3, 4, 5. I have 6 2's. How many do I need? 4, because my index is 4, right? So 2 raised up to the 4th power is 16. So 16 times whatever's left, multiply that together. 16 times 4 should give me 64, it does. So I'm going to rewrite this as 3 times the 4th root of 16 times 4. Now, is a squared a perfect fourth? Could I rewrite it so that it has perfect fourth factors? No, I don't have enough, right? Okay. Everybody cool so far? The 3 is already outside the radical, so I'll multiply it by anything else that I take out. We said 16 it has a perfect fourth, which is what? 2. We said 4. Is 4 a perfect fourth? No, because a lot of people say it's 1. Well, is 1 times 1 times 1 times 1 give me 4? No, 4 does not have a perfect fourth power. And we said a squared isn't either, right? So he has to stay. So my final answer should be 6 times the 4th root of 4a squared. It's kind of cool. I'll underline the different colors and you see where I got what, right? Does that help? All right, 7 through 10, the directions just say write each expression in exponential form, okay? That's all you're doing is writing in an exponential form. So on number 7, I'm taking the square root of 10m quantity raised to the 3rd power. So exponential form means get rid of the radical, write it with a rational exponent. So 10m would be my base. The whole thing is raised to the what? 3 over 2, because remember, the index, if there's nothing there, it's a square root, which means 2. Now, if you just put 10m raised to the 3/2, is that correct? No, because that's only the m being raised to the 3/2, but the whole thing is being raised to the 3/2. Okay? So that's all you have to do for those. So let's look at number 10. So that would be what? K raised to the 2/3. That's all you're doing. So I know there's 42 problems on this page, but several of them are just like that. Just convert it to radical form or to convert it to exponential form. Okay? So there's really no work to show on those. That's all you're doing. On the next page, 11 through 16, they're giving you the equation in exponential form, and they want you to rewrite it in radical form. So let's look at number 11. What would the index be? The 2, right? That's the index. What does the 5 tell you? Right, it's the exponent. So if I'm writing this in radical form, when it's square root, do I write anything as the index? No, that's implied, right? So 3m is all being raised to the 5th power. Or you could write the radical, like you could write it like this and put the parentheses on the outside. I believe software that I use to write your test, I think it does it with the parentheses, everything inside the parentheses, like the second part, like this one. Okay? That's all you're doing. Just rewriting it as a radical. All right? So look at 15. What's the index? 4. So the fourth root of 3b raised to the first power. And if your exponent is 1, is that that's not, they're not going to show you that, right? So you would just see the fourth root of 3b. Y'all cool with those? Those are easy. Easy points. 17 through 20, we are simplifying. Okay, simplifying. So remember, number 17, that 5, 6 is outside of the parentheses. So what's 64's exponent currently? 1, right? Not 6. Only P's exponent is 6. So remember, when you have a power to a power, remember when your exponent has an exponent, you keep the base and do what to the exponents? Multiply them. All right? This is not a product inside the, or I'm sorry, this is not a sum inside the parentheses. It's not, we're not adding two things, we're not subtracting two things, it's one term. So every part of that term has to be raised to the 5 6 power. So that would be 64 raised to the 5 6 power times p to the 6th raised to the 5 6 power, right? As your answer is not going to look like that though. So let me see, 64 raised to the 5 6. Let me write that as a radical and see if I could simplify that. What would be my index? So the 6th root of 64 raised to the 5th power times 6 times 5, 6. So 6 has an exponent or denominator of 1, right? So remember, when you multiply fractions, numerator times numerator, denominator times denominator, and that would reduce to 5. So I could simplify that real easy. It's just a 5. All right. 64 raised to the 5 6 is the same thing as the 6th root of 64. Okay, let me see if 64 has a perfect 6th root. It does. It's 2. So I can take the 64, the 6th root of 64 is 2, and then raise that to the 5th power. So 2 raised up to the 5th power is 32. So my final answer should be 32p to the 5th. I could have also done 64 raised up to the 5th power first, which is a gigantic, can't even say it, gigantic number, and then taken the 6th root of that and gotten the same thing. Gigantic. Yeah. Now you're messing me up. All right, so each one of those is different. All right, let's look at 19. So 64 is being raised to the 1/2, and x to the 4th is being raised to the 1/2. When you raise something to the 1/2, isn't that the same thing as taking the square root of it? So I can easily take the square root of 64, and x to the 4 raised to the 1/2. So 4 over 1 times 1/2 is 4/2, which equals 2. So simplify that to get x squared. All right, what's the square root of 64? So my final answer is just 8x squared. Coolio? Your test will not have this many questions on it, okay? All right, 21 through 28, we're having to simplify those. Remember, you got to remember your rules for radicals, okay? So remember, if you are multiplying and you have like bases, So like a to the m times a to the n. I'm multiplying. My bases are the same. The rule says keep the base and do what to the exponents? Add what? Add them. What if I'm dividing? What if I had a to the a raised to the m divided by a raised to the n? So you're dividing and you have the same base. The rule says keep the base, and that base would be up in the numerator, and do what to the exponents? Subtract. It's always the exponent of the numerator minus the exponent of the denominator. Okay? We already said power to a power. If your exponent has an exponent, you use the power to a power rule, which says keep the base and multiply the exponents. Okay? Okay. All right, so we got to remember these rules when we're doing 21 through 28. Let's look at 21. I'm multiplying these two things together. Coefficients, can't I do 2 times 4 and get 8? What's x cubed times x to the first? X to the fourth. What's y fourth times y cubed? Y to the seventh. That's all you're doing there. Let's look at 22. All right, what do I do when I have that negative exponent? I gotta bring it down to the denominator, right? If it's in the numerator, to get rid of the negative exponent, I would drop it in the denominator. So, but I can take care of that along the way. I have a coefficient. In the first term, my coefficient's 1, right? So we know 1 times 3 is 3. What's a times a? A squared. And what do I do with that b? Put it in the denominator, change the negative exponent to positive. Now, do I have like bases there? Could I? No. Is there anything else I could do? No. Coolio. Let's look at 25. All right, you need to take care of the power to a power first. Simplify inside the parentheses before you try to multiply them together. So in the first term, we know that's 2 raised to the 4th power times y raised to the what? Close. 8. Keep the base, multiply the exponents when you have a power to a power. Times y raised to the 3rd power, x raised to the 9th power. All right, can we simplify 2 to the 4th power? Yeah, it's 16. So I'd have 16. I'm going to put these in alphabetical order. X to the 9th, y to the what? What? 11. Anything else I can do? All right, one more. Let's do 28. All right, so I have a lot of stuff going on. In the order that I'm doing this, because there's several different things that you got to do, and the order does not matter, like moving the exponents around or combining them. So I'm probably going to go ahead, and if it's negative, I'm going to move it, and then I'll go back and simplify. And x to the 4th raised to the 2nd power is what? That's going to be x to the 8th, power to a power. All right, so I'm going to just... X raised to the negative 2 is in the numerator. That's going to go down to the denominator. Y raised to the negative 4, going to put that in the denominator. This x to the 8th, that's positive, so do I move that? No, I'm going to leave it, put it in the denominator. X to the negative 4 in the denominator, I'm going to move it to the numerator. And y to the 4, I'll move it to the numerator. I'm sorry. Stay in the denominator. Now let me simplify that denominator before I go any further. So if x to the fourth divided by x to the what? To the 10th? 10th, because x squared times x to the 8th is x to the 10th, right? When you're multiplying, keep the base, add the exponents. Y to the 8th. Can I do anything else to simplify? Don't I have x's in the numerator and in the denominator? Right? So I can simplify that. Remember, when you divide x to the 4th divided by x to the 10th, keep the base that's in the numerator, subtract the exponents. So isn't that going to give you x to the negative 6 in the numerator? So what do we do with it? It's already in the top. So I have to put it in the denominator, right? So what's left for the numerator? So what do I write? 1 over x to the 6th, y to the 8th. Now, when I, like those x's, this is how I think of it. I've got 4 in the numerator, 10 in the denominator. Where do I have more x's? In the denominator. So that's where they're going to end up. How many more do I have in the denominator than the numerator? 6. Notice I have x to the 6th in the denominator. That's how I think of it. I don't necessarily do this math. That's kind of done in my head, but that's what you're doing. Okay? Anybody have questions on that? All right. Next section, solve each equation. Remember to check for extraneous solutions. So radical equations, we have to isolate the radical before we can get rid of the radical. When you have a variable under the radical, right? So what would we do first on this one? Divide by 6. It's a little much. So that gives me the square root of 3x plus 24 equals 18. Now, I want to get rid of that radical. I cannot subtract 24 equals 3. Bless you. I can't subtract 24 and divide by 3 while it's under the radical. So, I want to get rid of it. What is the inverse of square rooting something? Squaring it. So, I'd have to do that to both sides. All right? So, the square root of 3x plus 24, quantity squared, is 3x plus 24 equals 3 squared is 9. Now I can just solve it like a regular old two-step equation, right? So I have 3x equals, what is 9 minus 24? Negative 15. If I divide both sides by 3, what does x equal? Negative 5. Remember, it's important to check your answers on these because you can get extraneous solutions. So I'm going to substitute negative 5. I can either go plug it into the original, or I can substitute it into the part of the equation where your radical is isolated, which is what I prefer to do. So that'd be the square root of 3 times negative 5 is negative 15. And negative 15 plus 24 is 9. Does the square root of 9 equal 3? Yes. So my answer is good.
What if it comes out to be a decimal when you're dividing?
That's okay. It could. I don't think any of these do. They all should work out to be non-decimal answers, but I mean, it could happen.
So 31 will work out.
Uh-huh. You should get negative 4 for number 31. Mm-hmm. All right, what do I do first on number 30?
You divide by 5.
On 30?
What? Hold on, what?
30?
No, 30. I'm looking at 32. My bad.
Oh.
You divide by 3.
Divide by 3. So you would get 5 equals the square root of x minus 1. Then we square both sides to get rid of that radical. So you have 25 equals x minus 1. X equals 26. So if I checked my answer, I'm going to check it once the radical is isolated. So 5 equals the square root of 26 minus 1, which is 5 equals the square root of 25. And that is a true statement. Coolio?
Like 31, like you know how you divide. Shouldn't you be divided?
What am I'm not dividing though?
You're subtracting the 7.
Right, because the 7's not being multiplied by the radical. It's 7 plus the radical. So on number 31, to get rid of that 7, you're going to have to subtract 7 from both sides.
And on 32, when you square the thing, you square the negative 5 as well.
Well, you got to add the 5 first, because you got to isolate the radical before you try to get rid of the radical.
Oh, okay. Never mind. No.
Okay, we're good? And there's 2 more on the back side too, 33 and 34. Do you have questions about either of those? 33, what do we do first? Subtract 8, and 34, what would we do first?
Divide by 9.
Divide by negative 9, right. Coolio? All right, 35 through 40, you're solving equations. This time they're not radicals, they're rational exponents. All right, no big deal. We pretty much do them very similar. So let's look at 35. All right, pretend that's a radical. It has to be isolated before you can get rid of that exponent, okay? It's just the parentheses have to be isolated. They are. So if something's being raised to the 3/2, if we want to undo that, we could raise both sides to the what? 2/3. Just the reciprocal, right? Because we know when we multiply by the reciprocal, 3/2 times 2/3 equals 6/6, which reduces to 1. And if we have an exponent of 1, then we don't need to write that and we don't need the parentheses anymore. But if we raise the one side to the 2/3, we have to raise the other side to the 2/3 as well, correct? So when I raise 729 to the 2/3, you're going to want to convert that to a radical. So what would the index be?
3.
So the cubed root of 729 squared. I don't really need parentheses because that's just one number there. I don't have variables or other numbers. Equals, on the right side, everything pretty much cancels out and leaves me with 4p minus 3. So I can either do on the left side 729 squared first and then take the cubed root, or I can take the cubed root of 729 then square it. So that's what I'm going to try to do, see if it's a perfect cube. So 729, take the cubed root and you get 9. But then you have to square it. 9 squared is 81. I have no radicals, I have no exponents. Now I can just solve this like a regular old 2-step equation. So I'll add 3 to both sides. I have 84 equals 4p. Divide by 4. And I get p equals 21. I'm going to check my work. So that's 4 times 21 minus 3 raised to the 3/2. So I'm going to simplify inside those brackets before I do anything with the exponent. And when I'm checking, I don't have any variables, right? So I'm not moving things to one side or the other of the equation. So 4 times 21 is 84. 84 minus 3 is 81 raised to the 3/2. So in radical form, that would be the square root of 81 cubed. Well, we know the square root of 81 is 9, and then 9 raised to the 3rd power is 729. So my answer is not extraneous. P does equal 21. Questions on that one? Yeah, I'll do another one. One or two more. Let's look at 36. Okay, I don't have parentheses, but I do have a rational exponent. I don't want to mess with it though until whatever that term is isolated. So what should I do first? Add 1 to both sides. Yeah, so we can isolate it. So 242 plus 1 is 243 equals n raised to the 5/4. What should I do? How could I isolate the n? Raise both sides to the 4/5, right? The inverse. Alright, so n raised to the 5/4 raised to the 4/5 is going to be n raised to the 20/20, which is just n. And then 243 raised to the 4/5, that would be the 5th root of 243 raised to the 4th. So let me see. 243, the 5th root is 3. And then 3 raised up to the 4th power is 81. So let me check my work. So that would be equals 81 raised to the 5/4 minus 1. So 242 equals the 4th root of 81 raised to the 5th minus 1 is not under the radical. So the 4th root of 81 is 3, and 3 raised to the 5th power is 243. And 243 minus 1 is 242. So n equals 81, works out. When I'm checking, yeah, if I was solving, yes, I would need to get rid of that 1. But if I'm checking, I don't have to because there's no variables. I'm just trying to see, does the left side equal the right side?
I think it's 81.
I took the 5th root of 243 and got 3, and then 3 to the 4th power is 81.
Oh.
You could have done 243 to the 4th first and then took the 5th root. It doesn't matter. You just have to remember to do both things. Are there any others that you could see that you look weird, like you're not sure what to do?
40, how would that work out? Like, how would you square this into the
On number 40?
yeah, if you had to come to a square root, how would it work?
Okay, so the parentheses are isolated, right? So what is the inverse of 1/6? 6 over 1, which is just 6. So 1/6 of 6 is just 1. So you're left with k plus 18 equals 2 raised up to the 6th power is 64. Subtract 18 from both sides. K equals 64 minus 18 is 46. And of course you'd want to check that. Any other questions? All right, so I know you only have 30 minutes to work on this, but it is worth 42 points. It is the last grade of the quarter. You want to make sure you have it completed. You do have a test on Thursday. I will leave the answer key up. Or hold on, I'm gonna shut this video off.